Hello there. I'm meteorologist Rick Mitchell. Welcome to my weather obsession. It is Wednesday night, a little bit after it's about 7:20, and of course we have some thunderstorms that are likely going to develop in our area overnight. What is the process that is going to generate these thunderstorms? What am I looking at? All right, that's what this video is about. This is where you want to come if you want to learn some stuff about how does he do that? How's that meteorological sausage made? That's what this is going to be. So let's start with, let me get over here and start with this. I want to show you what we're looking at here is a product that's showing the 500 millibar flow. Basically, it's the jet stream flow at about 18,000 feet. And if you'll notice, we got a little dip in the jet stream here over Southern California, Arizona. That is the storm system. And notice if I put this into motion, that storm system, I'm going to rock it back and forth here, is going to be making its way across Texas, especially North Texas, the Texas Panhandle, throughout the overnight hours on into early Thursday. That's what's going to generate our thunderstorms. Why does it do that? Well, it's got very low temperatures in the upper atmosphere. It's got very strong winds. Those both combine to produce lift in the atmosphere. If you want thunderstorms, you have to have lift. Everything revolves around lift when it comes to weather, vertical motions, okay? So over time, that storm system just kind of shears on to the northeast, but it will be enough to generate thunderstorms. Now, I want to look at soundings. What's a sounding? That's basically attached, it's weather equipment attached to a weather balloon that gives us an idea of what's happening through the different levels of the atmosphere. This is from this morning. This is actually Fort Worth's 12Z sounding. Red line is the temperature. As you go higher on the graph, you go higher in the atmosphere. So notice at the surface, it says the temperature this morning was 63. It started climbing and it started to decrease. As you go farther left, the temperatures go down. So as this parcel, or as this balloon went up, the temperature was decreasing up to about 5,000 feet. Then all of a sudden, bam, it warms up. At 5,000 feet, it was warmer than it was at 0 feet. Okay, this is a layer of warm air. This is what we call the cap. Once it lifted above basically 5,000 feet, then the temperature started decreasing again. But this is a very significant increase in temperature. This is a strong warm layer. Again, this is 6 o'clock this morning. The green line is the dew point temperature. So at the surface, they were fairly close together this morning. That's a moist atmosphere. And then all of a sudden, it really dried out when it got up to about 5,000 feet. And it stayed fairly dry until it got a little bit higher, up towards 25 or 30,000 feet. So the main thing I want you to see on this graph is the cap, okay? That was 6 o'clock this morning. Let's check out the sounding that they just took about an hour ago. And where'd the cap go? Okay, this morning, this evening. All right, the cap is gone. Thunderstorms have the green light. If they want to form, they've got the green light to go, okay, because the cap is no more. Now, one thing I'm seeing as I'm looking at this sounding here, I can look at what's called the CAPE. That's the available potential energy, convective available potential energy. And what I'm seeing is fairly meager numbers. In other words, the fuel for the thunderstorms is not that good. The shear is not bad, okay? This is a situation where we call it low CAPE. I wouldn't call it high shear. Sometimes we call it low CAPE, high shear. I'd say low CAPE, moderate shear. So despite the fact that the instability is not good, storms may be able to overcome that with having stronger updrafts that can manage to develop some severe weather characteristics. So in this case, again, the CAPE is not good, instability is kind of poor, and the shear is not bad. It's moderate. You know, it is February. So let's look at the latest high resolution rapid refresh model, also known as the HRRR. All right, this is just coming out as we speak. And to get your bearings, here's North Texas, here's DFW. Watch for the storms to form out to our west. Why are they going to be forming out there? Well, let's go back to our jet stream, right? That piece of energy moving out of Mexico and New Mexico into Texas. All that lift is going to manifest itself in the form of thunderstorms. The cap is gone, and so storms should feel free to develop as they wish. So that is, what time is that? That is 11 p.m. Storms developing out in West Texas and then progressing east. One thing I want you to note, as we go through time here, let's see, I've stopped it at 3 in the morning. Here's DFW. You got a thin line of thunderstorms here, more active storms, and certainly more widespread coverage up in Oklahoma. I think the conditions are more favorable in northwest Texas and southern Oklahoma. I think that's where, if I was, going to pinpoint where are there going to be some severe thunderstorm warnings, and you have one location to choose, that's the location I would choose. So with time, we're out to, that is what, 4 in the morning. And notice as that line's coming through DFW, it's pretty scraggly. From I-20 to the south, there's not much there. This lines up well with the slight risk area that is from I-20 on to the north. I still look at southern Oklahoma and areas along the Red River as having the better opportunity. Why? Well, the dynamics are better. The ingredients are a little bit better up there than they are down here. Remember, that upper system is going to be tracking across the Texas Panhandle and into northern Oklahoma. So we're a little bit away from the upper dynamics, the upper thermodynamics, and just think of it as the better ingredients are a little farther to the north. So that is, again, that is 5 a.m. There's 6 a.m. And by that point, that scraggly little line starts to shift on to the east. And we just get a strong cold front. Can you see these northwesterly winds? That's the cold front, and that's going to drop our temperatures from maybe 60 at 4 a.m. Into the 40s by 9 a.m. So big old cold front coming through. The rest of the day, this line continues to progress on to the east. Go to the Storm Prediction Center page. They have a enhanced risk for severe weather in portions of Mississippi and Alabama tomorrow, and areas, I think areas to the north. But that system will continue to tap into better ingredients as it moves farther on to the east. So what we're looking at here, what is causing this? It's the jet stream energy, the storm system that's moving out of Mexico and New Mexico. That's crossing West Texas, Texas Panhandle, Oklahoma. That increases lift in the atmosphere. It increases the instability because the air at 18,000 feet is very cold, and you've got very strong winds at 18,000 feet, and that's also helping to enhance the lift. Now, what we don't have is a lot of instability here at the surface, at least not around here. We've got moderate shear. That's enough that we could see some thunderstorms capable of some gusty winds and hail, and maybe a couple of brief tornadoes that can spin up on the leading edge of this line of storms that I think is more favorable across northwest Texas on into southern Oklahoma. So that's my 2 cents on that. We'll see how it goes. In any case, I think it's going to be for DFW near sunrise when we see these thunderstorms, and then it's just cold. So thanks for watching. Hope you learned something. If you like what you saw, follow, like, do whatever. Just be interested in the weather. All right. See you later.